Hi dear students, welcome to Sri Chaitanya Bridge classes. How are you all? Good evening, good evening. Yeah, in the last class we've discussed coordinate system, right? So we shall continue the discussion. So coordinate system is a very important part as far as JEE is concerned. So we can say in this particular coordinate system, we also after introductory things, we study straight lines, circle, parabola, ellipse, hyperbola in our regular classes. Here my aim is to provide the required stuff, required bridge things, fundamental things related to coordinate geometry. Are you all ready dear students? Ready? Clear everyone? Now is the voice clear? Yes. Be non-negative. Yes. Yeah. Number is the ruler of the universe. Yes, all of you text guys. Number is the ruler of the universe. Come on. Yes, thank you. Thank you very much. Yeah. So coordinate system. Coming to today's lecture, coordinate geometry we've started yesterday. Good evening Charan. Good evening. In coordinate geometry, you see let us recollect the important point that we have discussed in the previous class. The first point is the same Euclidean geometry we study with the help of algebra, that is nothing but coordinate geometry. Namaste Dheeraj. Dheeraj. Yes. Good evening everyone. So be non-negative. S. Yeah, Deshmukh. Fine. So coordinate geometry part dear students, René Descartes is the mathematician known as father of coordinate geometry. So in previous class, that is yesterday's class, we've seen how to plot a point in xy plane, the relevant coordinate system related concept we've discussed. Yes, Hasini, good evening. Ravinder Reddy, good evening. Yes. Yeah. Then we discussed how to find distance between any two points in the plane when the coordinates are given. Then section formula also we have discussed. At section formula there are multiple formulae are there. Okay, low volume. Let me try to raise my voice. Yes, yes. Everyone? Yeah. Now in today's class we are going to give now what about the voice? Is it clear now? Voice part? Now audible? Now check the voice. Is it clear? Fine, thank you, right. Now dear students, in today's lecture we are going to give some important shortcut related to, yes, in today's lecture we will discuss area related formula, especially area of a triangle, area of a quadrilateral, polygon, followed by some more important things. Stay tuned to me, I will provide even shortcut for this. So are you all ready guys? Shall we start? Come on. So give a thumbs up here. We'll see. Show your readiness. Yes, everyone. Right? Okay. Chalo. Now, area of a triangle. Suppose if you are given three vertices of a triangle. Suppose this is triangle ABC, where the coordinates are x1, y1, x2, y2, even x3, y3. Suppose these are the three coordinates of the vertices given. How to find area of the triangle? So the students who are studying, who studied, so Andhra or Telangana State Board, so you might have known the formula already. For CBSE students it's a new thing. So listen to me carefully. So to find area of the triangle, the formula is area is half modulus determinant. You do one thing, just write first vertex x1, y1, then second x2 y2, then third x3 y3, and repeat the first, You have to write this first. Clear everyone? Is it clear? How to find area of the triangle when three vertices are given? It is very simple, dear students. Area is half modulus determinant first point, second point, third point, and repeat the first point, right? If you repeat, now what you need to do is half. So like determinant, 2 by 2 determinant, x1 y2 minus x2 y1. You see, x1 y2 minus x2 y1 plus, then second x2 y3 minus x3 y2, x2 y3 minus x3 y2 plus, again this determinant, x3 y1 minus x1 y3. So this number you are going to get mostly positive. It may be negative also. If negative, you have to apply modulus so that you are going to get the area of the triangle. Right everyone? So the same formula is written in many formats in books, x1 into something, all are the same, nothing to worry about it. So the formula that you are texting here in the chart is also fine, all are the same, little bit of alignment of the terms here. Right. Now dear students, let us try a problem how to find area of a triangle. All of you try. Find the area of the triangle. Find the area of the triangle formed by, you see, 2, 3, 1, 5, 6, minus 1. Come on. All of you please try. Let me know the answer. Quick, quick, quick. So find the area of the triangle whose three vertices are these. Come on. So dear students, the formula is half modulus. You just write like first vertex, second vertex, third vertex, and repeat the first. You can start with any of the vertices, no problem, because it is a triangle. Now this is half modulus. You see, so you see how I am going to do, listen to me. This is 10, add, this is minus 1, 10 minus 1 plus 18. This you do at a time, minus of, you see, 3 plus 5, 6 are 30 plus this is minus 2, okay, which gives, yeah, this is 28 minus 1, 27 minus, this is going to be 31, where the difference is 4, 4 by 2 will give you 2 square units is the area. Clear everyone? 2 square units is the area. Fine everyone? So to find area of the triangle when three vertices are given, the simple procedure is half modulus. You repeat first vertex, second, third, and repeat the first. So you can also do like, you see, first step, this plus this plus this. This is the first step, guys. Okay, minus of this plus this plus this. Okay, so shall we do one more question? Shall we do one more question? Ready? Are you all ready to do one more question? Yeah. Now you just see, try to find area of the triangle with vertices 2, 4, 5, 1, 1, 6. Yeah, come on, try please. Try all of you. Let me know the answer. Quick, quick, quick. What is the area of the triangle? As quick as possible, you try to give the answer. Let me see who can give the answer. Area of the triangle formed by these three vertices. I write like half modulus, first vertex, second, third, and repeat the first. The next half modulus, you see this is 2 plus 30, 32 plus 4, 36 in one step, minus, you see 20 plus 1, 21, 21 plus 12, that is 23, 33. You will get 3 by 2 square units, that is 1.5 square units. Absolutely correct, 1.5. Jitendra, maybe the first who has given the answer, even Agneshri also. Fine. So the answer is 3 by 2. Is it clear everyone how to find area of the triangle when 3 vertices are given? Clear? Clear everyone? Right, good. Good, good. Now, dear students, suppose, absolutely correct, 3 by 2 is the right answer. If one vertex is 0, 0, other vertices are x1, y1, x2, y2, what about the area of the triangle? Listen to me carefully, it gives us a wonderful shortcut. So, out of the 3 triangles, if one vertex is 0, 0, how to find area of the triangle? So, it is very simple. Actually, I have to write like half modulus 0, 0, x1, y1, x2, y2 and repeat 0, 0, which gives half modulus. You see, this is 0, this is x1, y2, this is 0, minus this is 0, this is x2, y1, this is 0. It is very simple, dear students. If one vertex is 0, 0, one vertex is 0, 0, it is simple half modulus product of the extremes x1, y2 minus product of these means kind of x2, y1. You just remember like this. It is very easy to find the area if one of the vertices is 0, 0. Correct? Correct everyone? Correct? You try to find area of this 0, 0, 7, 5, 2 minus 3. Find the area of the triangle. Quick, quick. Let me see who can answer. Area of the triangle with vertices 0, 0, 7, 5, 2 minus 3. Quick. This is, yeah, I'll give time. Please, Agneshri, please try. Please try. I'll give time. Try to find the area. Area of the triangle whose one of the vertices is 0, 0. Come on, come on. Yeah. This is half modulus. If one vertex is 0, 0, it is very easy directly. Minus 21 minus 10, which is 31 by 2 is the area. It saves lot of time. Am I correct? It saves lot of time, right? Correct? Fine. Now, dear students, yeah, suppose you try to answer this, try to find the area of the triangle with vertices 1, 3, 7, 5, 9, 4. Quick, all of you. You just do the question. I will provide a beautiful shortcut for this. You just try first, then I will give the shortcut. Try to give the answer as quick as possible. Try to give the answer as quick as possible. Yes. Yeah. Yes, what is the answer? Area should be a positive quantity. So, modulus you apply and let me know the answer. Right? Okay, 5, 10, 5, 5. Okay, right. So, you might have done in a specified procedure. Guys, shall I give a shortcut? Are you all ready? Are you all ready? Shall I give a shortcut? Shall I give a shortcut than what we have done earlier? Shall I give? Yeah, you see, one of the vertices you select, you subtract that from all the 3. You select one of the vertices. You see 1, 3 is easy to subtract. Subtract one of the vertices from all so that this becomes 0, 0. If you subtract 1, 3, this becomes 6, 2, this becomes 8, 1. Am I correct? I have subtracted 1, 3 from all the 3 so that it has become 0, 0, 6, 2, this is 8, 1. Now you just apply the shortcut half modulus x1, y2 minus x2 y1. 5 square units is the answer. Is it clear? Arey yaar, do you understand this? Do you understand this, guys? Even though no vertex is 0, 0, no vertex is 0, 0, by subtracting one of the vertices, you can make it 0, 0. Okay? So that if one vertex is 0, 0, yeah, it is very easy, you can find the area. Even though the vertices are different, they will get the same area. Got it? Those who like this, give a like. Yeah. Fine. Next, dear students, try one more question to find area of the triangle formed by, you see, let me write here. Yes, this is 5, 2, 8, 1, 9, 7. Find the area of the triangle formed by this. Come on, quick. Yeah, find the area of the triangle formed by this. Area of the triangle formed by this. Quick, quick. Try guys. Area of the triangle formed by this. Let me know the answer. Who gives it correctly and accurate and speed I want. What is the answer? Right? Okay. Okay, nice. Nice. You see, you can select one of the vertices and subtract. You can subtract any. Let it be 5, 2, which becomes 0, 0. If you subtract 5, it becomes 3. 2 means minus 1. Subtract 5, 4. 2 will become 5. One vertex is 0, 0. Half modulus x1, y2 minus x2, y1. 19 by 2 is the area of the triangle. Got it, everyone? So, dear students, so you won't get 0, man. So, I have taken this out. So, the previous one also, it is not 0. I erased it, but it is okay. So, everyone, I think by this term you have learned how to find area of the triangle, how to find area of the triangle when 3 vertices are given. Clear? Kiran Sai. Now, let me try to give with louder voice. Yeah. Next, dear students, once you know area of a triangle is this, collinearity of 3 points. If 3 points are said collinear, if 3 points are said collinear, you know what happens is, so there are multiple methods to apply the condition. For example, dear students, 7, 2 is 1 point, 1, 8 is 1 point, say 6, k is other point. So, if these 3 points are collinear, so what, find the value of k is the question. If these 3 points are collinear, find the value of k. So, we have many methods. If you know slope, straight line, we will do later. But in this stage, you can also apply the point that area of the triangle formed by ABC would be 0. So, for that, you can subtract 7, 2 from all. This becomes 0, 0. If you subtract 7 minus 6, 8 minus 2 is 6. This is minus 1, k minus 2. These 3 points are collinear. So, dear students, half modulus AD means minus 6k plus 12 minus BC will become plus 6. This must be 0. So, minus 6k plus 18 equal to 0. So, you will get k value to be 3. Right? If 3 points are collinear, Kiran Sai, I am trying my best. If 3 points are collinear, so what condition will you apply? What condition will you apply? So, if one of the numbers, one of the coordinates is unknown, you can simply apply the condition that. So, if 3 points are collinear, area of the triangle will be 0. Okay, that condition apply. Of course, further in upcoming classes, you will get, will get little more easy concepts for handling collinearity. Now, area of a quadrilateral, guys. If 4 vertices of a quadrilateral are given, say 4 vertices of some quadrilateral are given, say A, B, C, D, where A is x1, y1, B is x2, y2, C x3, y3, D x4, y4. If these are the 4 consecutive vertices of some quadrilateral, how to find area of this particular quadrilateral? Okay? Okay, right? So for that, dear students, suppose if you don't know the formula, you can also do, just join this. You find area of triangle ABC, area of triangle ADC, you can add. It's simple, right? You can also do that, right? It is simple analogy, simple logic to find this. But still, voice is low. Now, what about the voice? Is it clear? Is it clear? Is the voice clear now? 1729. Gopi, thank you. 1729. Ramanujan number. Ramanujan number. 12 cube plus 1 cube. Right? Chalo. Yeah, dear students, rather this procedure to find the area of the quadrilateral when 4 consecutive vertices are given, the simple formula is, guys, same like triangle, half modulus determinant, first vertex in the cyclic order. You can start anywhere, but you have to continue in a cyclic order. x1, y1, then next x2, y2, x3, y3, x4, y4, and repeat the first. Same like triangle, you have to write the 4th vertex, that's it. So if 4 consecutive vertices of a quadrilateral are given, so you have to find the area of the quadrilateral. What is the procedure? Half modulus determinant x1, y1, x2, y2, x3, y3, x4, y4, and this. After this, you know how to handle this determinant plus this, plus this, plus this. Okay. Shall we take up a question, guys? So try to find area of the quadrilateral formed by, suppose this is A, B, C, D. Yes, come on. You can write 1, 3, 2, 5, 3, 1, 4, 6. Come on, all of you please try. All of you please try how. So to find area of this particular quadrilateral. Area of this particular quadrilateral, how to find? You just see. So, voice part, is it clear now? Is it clear voice now? Those who are feeling voice little low, is it clear now? Prithvi, okay? Yeah. So we shall continue in this way. So dear students, yeah, all of you please calculate the area of this quadrilateral formed by the given vertices. Right, guys, here you can start with any of the vertices, but you have to carry in the cyclic order, that is important. So area is half modulus, first vertex 1, 3, second is 2, 5, third 3, 1, fourth 4, 6, and repeat the first, don't forget. Okay. So now, guys, this is half modulus. You see how I am going to do? All these first 5 plus 2, 7, 7 plus 18, 25, 25 plus 12, 37. All at a time, minus, next time this, 6 plus 15, 21, 21 plus 4, 25, 25 plus 6, 31, right? Yeah, 31. So which is going to be 3 square units. Is it correct? Is it correct? Just check, dear students. So we can see multiple answers in the options, 9 and all. 3 is the right answer, right? Fine? Okay. So voice is not clear. Okay. So guys, I mean to say here, meanwhile you just complete this. You just complete this. right? So we shall see, dear students, area of the quadrilateral. Area of the quadrilateral when 4 consecutive vertices are given. So what we have done, half modulus first, second, third, fourth and repeat the first. Okay, here itself guys, I'd like to give one more shortcut I'd like to give, that is, you see, for especially for quadrilateral you can also do half modulus 1 minus 3, like x1 minus x3, y1 minus y3, 2 minus 4, x2 minus x4, y2 minus y4 will also work for area of a quadrilateral. Okay, for area of a quadrilateral it can go like this way also. It is easy. You just write half modulus 1 minus 3 means a minus c, 1 minus 3 minus 2, 3 minus 1, 2. 2 minus 4, 2 minus 4 will become minus 2, 5 minus 6 will become minus 1, which gives half modulus, this is 2 plus 4, 6 by 2, 3 square units. You can also find area of the quadrilateral in this way, right dear students? Clear everyone? Clear? Area of the quadrilateral can also be found like this. Okay, right, one more question we shall try here. So just find the area of the quadrilateral guys, area of the quadrilateral with vertices 3, 6, 1, 2, 5, minus 1, 2, 4. Yes, quick, try to find area of the quadrilateral formed by these 4 consecutive vertices. For a discriminant is not required. Yeah, chalo. So dear students, to find area of a quadrilateral easily, half modulus 1 minus 3, 3 minus 5 minus 2, 6 plus 1, 7. 2 minus 4, 1 minus 2 minus 1, 2 minus 4 minus 2, which gives, this is 4 plus 7, which is 11 by 2 square units. Clear? Check once your answer. 1 minus 3, 3 minus 5 minus 2, 6 plus 1, 7. 1 minus 2 minus 1, 2 minus 4 minus 2. Half modulus AD is 4 minus BC is 7. 4 plus 7, 11. 11 by 2 is the right answer. Is it not a quick method to find area of the quadrilateral guys? Area of the quadrilateral, right? Clear? Previous question model itself, this is area of the quadrilateral, you can find like this. And one more point, if you want to find area of some polygon, you can say like here, suppose you are given some polygon with n vertices. Yeah, suppose this is some polygon with, if consecutive vertices are given, but still you can find the area like half modulus first vertex, second, you have to take in order, third and so on. You write the nth vertex and repeat the first guys, and repeat the first. This will help you to find area of the polygon. So dear students, in today's lecture, so far we have seen how to find area of a triangle, especially if one vertex is 0, 0, we have a wonderful technique. How to find area of a quadrilateral, regular method and shortcut method. Second one, yeah, again say that, I mean to say how to find area of a polygon, you can do like this. Okay, so check the procedure how we are doing. Okay, calculations you can do, not a big deal. You just try to observe the procedure how we are explaining. While taking vertices of a quadrilateral, you should not, I mean to say, alter the order of the vertices, right? Next, chalo. Next, very, very important one. So, finding fourth vertex of a parallelogram. Guys, what is a parallelogram? What is the simple definition of a parallelogram? Can anyone in the class? What is a parallelogram, guys? Parallelogram is a figure simply formed between two sets of parallel lines. That's all. Parallelogram is a figure formed between two sets of parallel lines. So, in fact, a parallelogram is a figure in which opposite sides are parallel. So, obviously, other properties will follow as results, like opposite angles will be equal, adjacent angles will be supplementary, opposite sides will be equal. There are properties and observations. But basic point is, for this is, you can say for a parallelogram, opposite sides are parallel. And one of the most important properties of a parallelogram is, you take any parallelogram A, B, C, D, okay. So, the diagonals bisect each other. Diagonals bisect each other, guys. Okay. Diagonal bisect each other means AC diagonal is bisected by BD. So, these two, suppose let me name it as E, these two will be equal. And BD diagonal is bisected by this. That means DE is equal to EB. This is the point. And hence, dear students, I mean to say, can I say that in a parallelogram ABCD, midpoint of BC, midpoint of AC is equal to midpoint of BD, correct? Midpoint of BD. This is a beautiful property which helps in answering many questions related to parallelogram. Okay. So important result. All of you please note, in a parallelogram, diagonals bisect each other. In a parallelogram, diagonals bisect each other. Okay. So, midpoint of AC is equal to midpoint of BD. Suppose if I give the names to these vertices, like, let it be x1, y1, this is x2, y2, this is x3, y3, and this is x4, y4. Okay. In this case, dear students, midpoint of AC you can write like x1 plus x3 by 2 comma y1 plus y3 by 2 is equal to x2 plus x4 by 2 comma y2 plus y4 by 2. Okay. Which means, to remember easily, shall I just write like A plus C by 2 is equal to B plus D by 2? Yes. And hence, dear students, in a parallelogram, most important thing, if A, B, C, D are 4 consecutive vertices of a parallelogram, you will observe that A plus C is equal to B plus D in vertices. For example, dear students, you got the vertices like 1, 3, 4, 5, 8, 1. This is going to be, if you are asked to find the fourth vertex in a parallelogram, you see here A plus C, 1 plus 8, 9 in the sense, for 4 it will be 5, 3 plus 1, 4 in the sense, for 5 minus 1. These 4 will be the consecutive vertices of a parallelogram. So, in a parallelogram, if you are given 3 consecutive vertices, how to find the fourth vertex? You see, suppose this is a parallelogram. So, this is, you see, 1 comma 3, 4 comma 5, 8 comma 1. What about the fourth vertex? You see, in a parallelogram, diagonals bisect each other. Diagonals bisect each other in the sense, simply this is 1 comma 3, right? So, you can say, dear students, yeah, simply if you want this vertex, subtract the opposite one, add these two. 8 plus 1, 9, 9 minus 4 is 5. 1 plus 3, 4, 4 minus 5 is minus 1. This is a very, very useful result, dear students, finding the fourth vertex of the parallelogram, right? So, we shall do one more question here. Try, guys. All of you please try to answer. There is a parallelogram. This vertex is 6 comma 3, 2 comma 5, 4 comma 7. Can you find this vertex? It is a parallelogram. Can I expect the answer, guys? All of you please text, calculate, come on, quick, all of you, try. Yeah. Many of you didn't like the video. Right. Okay. So, you see, it is 6, 3, 2, 5, 4, 7. Okay. So, what we can do for the fourth vertex is, guys, yeah. So, whatever vertex you want, opposite one you have to subtract, add these two and subtract. 6 plus 4, 10, minus 2, 8, 3 plus 7, 10 minus 5, 5, 8 comma 5. Superb, dear students, wonderfully answered. Superb, very nice, very nice, very nice. Good, good, good. Fine. Okay. Next, now try to answer this. Suppose there is a triangle ABC. All of you listen to me. ABC is a triangle. Okay. Now, midpoint of BC is D. Midpoint of AC is E. Midpoint of AB is F. Given D is 3, 4, E is 7, 1, F is say 6, 2. 6, 2. Okay. So, let me repeat the question, dear students. Let me repeat. Given triangle ABC, where D, E, F are the midpoints of the sides. BC midpoint is D and E is the midpoint of AC and F is the midpoint of AB. Can you find ABC? Come on quick. Can you find ABC? Can you find ABC? So, first you try to find C. Can anyone say what is the vertex C? Right? Quick, quick, quick. It's a good question. First you try to find C, all of you. Let me know C. C value. Quick. Yeah. Just I am waiting who will answer first. Okay. Hasib Akhtar. Dr. Tulsi Krishna. Okay. 4, 3. Fine, dear students. Superb answered, well answered, wonderfully answered. You see, first point here is you can observe the point. You see, in a triangle, if we join the midpoints of the sides, there is a beautiful theorem, midpoint theorem. A line segment joining midpoints of two sides of a triangle will be parallel to third side and half of it. Okay. A line joining two vertices of a triangle will be parallel to third side and half of it. So, definitely this must be parallel to BC. So, we can say this. Similarly, you join these two. This must be definitely parallel to this. Correct? Because these are midpoints of two sides, it must be parallel to this. Now you can observe that, you see, EFDC is a parallelogram. EFDC is a parallelogram for which, you see, 3 consecutive vertices are known. I want the fourth vertex. Come on quick, add these two and subtract this. 10 minus 6, 4, 5 minus 2, 3. 4, 3 is absolutely right answer. Superb. Well done. So, after finding C, how will you find B? Come on. How will you find B? Yes, Hasib is the topper. Answered. Kaushal, he answered very quick. Yeah. Yeah. Now, can you find B? Can you find B? Can you find B? So, C is given, D is given, B. Yes, wonderful, Dr. Tulsi Krishna. Superb idea. So, you can also do one way. If you join these two, here again it is a parallelogram. So, it is again same parallelogram. You can subtract this, you can add. 6 plus 3, 9. 9 minus 7 is 2. And 4 plus 2, 6. 6 minus 1 is 5. 2, 5 is the answer. 2, 5 is the answer. but rather this is a line segment. You know midpoint, you know one end point. Yesterday I told you A, B, M is the midpoint. If you know one end point, midpoint, the other end is double the midpoint and subtract this. Double the midpoint and subtract this. 2M minus B. Here also double it and subtract 6 minus 4, 2, 8 minus 3, 5. It's very easy than the parallelogram, right? Correct? Now in the same way, try to find A, guys. Try to find A. Try to find A. Come on, quick. Quick. Yeah. This is, again it is a line segment. Midpoint is known. Double the midpoint and subtract. 12 minus 2 is 10. 4 minus 5 is minus 1. 10 comma minus 1. Superb. Well answered. Well answered. Superb. Superb. Okay. Right? Yeah. Fine. Chalo. So dear students, so far in today's lecture, we've covered how to find area of triangle, right? We can also subtract one of the vertices and make it 0, 0, then apply the shortcut. Second, how to find area of a quadrilateral, some quadrilateral. Same logic, generalized procedure, half modulus x1 y1, x2 y2, x3 y3 and repeat the first. Okay. Then next, how to find area of a polygon. So for that the same procedure, we can write the vertices in the same order, same cyclic order, and you can apply the shortcut. Then finding fourth vertex of a parallelogram. Fourth vertex of a parallelogram. So with the help of which we have done one observation also. These are the 4 things we have learned today, whereas yesterday distance formula, section formula we have covered. Okay, right? And dear students, next, how many types of parallelograms are there? Quick, quick, come on. Can somebody say how many types of parallelograms are there? How many types of parallelograms are there? Can somebody say, dear students? Yeah. How many types of parallelograms are there? 4. Okay. Arey yaar, it's very simple, basic geometry, but this is very, very important. Let me recall the important points related to geometry. This, you know, a trapezium is just a figure in which opposite sides are parallel. If not all, if a pair of opposite sides are parallel, we call it as trapezium. Point number 1. In a trapezium, guys, only one thing you can say, sum of these two angles is 180 because these two are parallel. This is a transversal. This is alpha, this is pi minus alpha, this is beta, this is pi minus beta. That's it. Isosceles trapezium is that where these two will also be equal. That means symmetry will be there. This is isosceles trapezium, guys. This is isosceles trapezium. This is fine. I am not going to worry about it. Now, parallelogram. Parallelogram. A parallelogram is a figure in which opposite sides are, two pairs of opposite sides are parallel. Okay. These two are parallel. These two are parallel. What are the following? Yeah, why trapezium came in the sense, parallelogram is a special case of trapezium. So, can I call a parallelogram a trapezium? Yes, it's a trapezium. Yeah, definitely it's a trapezium. It is a special case of trapezium. This is why trapezium came. Okay. Now, in a parallelogram, generally these two sides need not be equal. These two angles need not be equal. If you are given what is the parallelogram in which all sides are equal, can someone say please? What is the parallelogram in which all sides are equal? All sides are equal. Come on. Let me get the answer. Yes, very nice, Jitendra, right? Super. Yeah. Square comes later, not rectangle, it is rhombus. Do remember, a parallelogram in which all sides are equal, we call it as rhombus. This is just a parallelogram like this, rhombus. Okay. So a rhombus is also a parallelogram. So it gets all the properties of parallelogram, like opposite sides equal, opposite angles equal, diagonals bisect each other. But a very, very important property that you can experience here is diagonals perpendicularly bisect each other. Do remember, rhombus, if it is given, mostly in the problems you are going to apply this property. So whenever a rhombus is mentioned in the problem, mostly you are going to apply this property in the problem, that is diagonals perpendicularly bisect each other. Okay. Now dear students, what is the parallelogram in which all angles equal? Come on. What is the parallelogram in which all angles equal? All angles equal. Quick. We are left with only 5 minutes. So what is the parallelogram in which all angles are equal? Rectangle. Superb. Rectangle. A rectangle is a figure in which all angles, rectangle is a parallelogram in which all angles are equal. Okay. Now you may also say square, but dear students, a parallelogram in which both the conditions are fulfilled, that is all sides equal and all angles equal, such a parallelogram is called square. Square. Okay. Square. So dear students, I mean to say, if you take set of all trapeziums, suppose this is trapeziums, now in this our all parallelograms will be subset of this. Parallelograms will, because every parallelogram is a trapezium, because you can find a pair of opposite sides are parallel. Now out of these parallelograms, if I just want those parallelograms where all sides are equal, we call it as rhombus. Rhombus. All angles equal, we call them as rectangles. Rectangles. And the intersection part is squares. This is the Venn diagram related to this. Clear everyone? Clear guys? So this is the Venn diagram related to all this. Now this is all because, dear students, you will be given certain vertices. You need to identify what kind of parallelogram they are going to form. So suppose you are given A1, 3, B2, 5, C8, 1, D you can say 7, minus 1. So ABCD form what kind of parallelogram? It is rhombus, rectangle, square, or just a parallelogram? This will be the question, guys. Okay. So dear students, so this is a question. There is a procedure, simple procedure to answer this question, right? Venn diagram in sets, no sir. Yes. In sets Venn diagram to understand the points only. Okay. Anything is to understand the things, right? Yeah, dear students. Okay, fine. How to find the type of the parallelogram will be discussed tomorrow, and after this, most important thing that we are going to discuss tomorrow, geometric points of a triangle, a wonderful topic, very, very useful topic. In straight lines, you take any JEE mains question, most of the times question is being given on geometric points of a triangle. Okay, right? So dear students, so this is the point. So before I close today, the important point that I would like to recall once today, coordinate geometry is nothing but studying the same geometry with the help of algebra. René Descartes is the father of coordinate geometry. He has given the idea to represent a point with an ordered pair. So first we have seen coordinate system, how to plot a point. The next, distance formula, section formula. There, dividing AB in the ratio m is to n internally, externally, midpoint, points of trisection, finding the ratio in which px comma y divides AB. All these things we have seen. Even harmonic conjugate. Then next, in today's lecture we have seen how to find area of the triangle when 3 vertices are given, shortcut method. Area of a quadrilateral when 4 consecutive vertices are given, even shortcut method. Area of a polygon and how to find 4th vertex of a parallelogram when 3 consecutive vertices are given, right? And we've seen types of parallelogram. We could recollect, a simple procedure can be applied. So dear students, before we leave, all of you, please like our video, subscribe to Sri Chaitanya channel. Everyone like the video who are watching the video. All of you like it, subscribe it, and so that it will be helpful for most of your friends who are going through our bridge classes. All of you guys, that is all for today. So see you tomorrow with your, so I know your energy is superb. Yes, tomorrow's topic, don't miss. It is a wonderful topic related to geometric points of a triangle, that is orthocentre, circumcentre, Incentre and centroid related properties. That's all for the day, dear students. Catch you tomorrow. Until then, bye. See you.